Hello. This video we're going to talk about cosecant, secant, and cotangent graphs. So let's first take a look at cosecant. And for this graph, I drew the sine wave at the bottom in orangish yellow or whatever that ugly color is, just to kind of refresh your memory. Remember, cosecant is the reciprocal of sine. So when we're thinking of this sine wave at the bottom, we want to think, all right, what's the reciprocal of that? So sine here at this point, that represents at 0, the midline there would also be 0. So now if we take the reciprocal of 0, we end up with undefined. So you can see wherever these on the sine graph hit 0, then there should be an asymptote line to represent that in the cosecant graph. Okay, so that's where the red asymptote lines match up. And then on the sine wave here, at that point right there, that would represent 1. If we take the reciprocal of 1, that is still 1. So you can see that represented on the graph right there. That gives us cosecant of pi over 2 would be then 1. Okay, and by the same token, if this is -1, then we take the reciprocal of that, then we would get -1 on the cosecant graph. And that's really how we end up generating the cosecant graph, is just kind of looking at the sine wave and then doing the reciprocal. So, all right, let's take a look at amplitude. Amplitude, remember, here, by the definition, here would be undefined. The period is 2 pi. Be careful here that you don't just look at just this section and say, oh, that's only a pi. Remember, it's got to repeat, so it's got to have that section plus this section. So that distance right there has to be together to indicate our whole period there, okay? The asymptotes you'll see on the graph are at 0, pi, 2 pi, continuing that way, and then -pi the other way. And that's pretty important. It also makes the graphing this pretty easy. All right, secant. When we're looking at the secant graph, remember that's the reciprocal of cosine. So at the bottom I drew kind of a quick sketch of cosine, again in that ugly color. And when we look at this particular graph, again, wherever you see it hitting 0 is where you should have an asymptote line on the secant graph. So you notice here that's 0, so we have an asymptote line represented right there, okay? And on the cosine wave, remember it starts at 1, so when we take the reciprocal of that, we still get 1, which is how we get that point right there. And then here now at -1, so also at -1 right here. And we just continue that process. Again, the amplitude here is undefined, and the period is 2 pi. This is one of those graphs that also splits part of the period in between the y-axis, I guess, cuts it in half. Our asymptotes lie at odd multiples of pi over 2. So you see 1 pi over 2, 3 pi over 2, etc. All right, that's the secant graph. And then lastly, cotangent. Cotangent is really, you can see the graph is just flipped around. It's moved a little bit, so I drew tangent on the bottom there, again, to try to represent and see the correlation between the two. In the tangent graph, where you see 0 here, there we go, where we see 0, again, that should be represented with an asymptote line right above there in the cotangent graph. So you'll see that throughout. And then when tangent is 1, then the reciprocal of that would also be 1, so that's represented up there. Okay. And then same thing here. This is -1, so we have -1. Reciprocal is -1 as well. So hopefully that makes sense as you're looking at it. The amplitude, again, undefined. The period here is only a pi. because it repeats then again. This also makes this, in my opinion, the easiest graph of these three, because the asymptotes lie at 0, pi, 2 pi, and the period is only pi. So it makes it a little bit easier to graph these. All right, that's a quick recap of cosecant, secant, and cotangent graphs. All right, see you later.